Hello everyone. Welcome to another of our AI Learning Club syncs. And today it's not about the book, but about a survey, which was a very interesting subject list for me. It's called Automatic Prompt Optimization. It was a blog post, more like a survey released last week. And it's a very interesting overview of how to automate creation of prompts. So as usual, I'm going to give a quick overview of the paper or the subject, and then we can discuss it later. So it starts by defining what is optimization. So you can either you have a curve of some reward or some score, and you want to decide what's the best, either what's the top or the bottom. So they are analog problems, but you want to decide like the extreme of this curve. So you have two different approaches. One is a gradient based, where you take a point, you move, you nudge to some direction, and then you see if it has you have the delta over the value. And since this has decreased, the next one will be here. And since this now the value has decreased a little bit, it goes backwards. Actually, this should be like this for it to be right, for it to go backwards, because it has increased uh, the value, so it goes back to this one. So this is what is called a gradient. It's more like a differential approach. And a gradient-free approach is more like I create a lot of points and I see the values, and then I pick some of them and I try to look closer to them. So in this case, this is the best of my first trial. Then I put a lot of points around that first value, and this allows me to like iteratively find the most optimal place. One of the advantage of this, the graded one, is that they have momentum. So they are targeted. They are not a random search, but they only provide one value towards the end. While the gradient free is more like non-guided, more random, but they provide um, a lot of candidates towards the end, which might be something good depending on the problem. So the goal of the automatic prompt optimization is given that you have a given you have a prompt or a problem, or like given a prompt or a task, because you can also start to do this without a prompt itself initially. Can you automatically find the prompt that better that achieves that task? Um, And one of the prerequisites for this is that we can identify what's better. This sounds like a little bit like obvious, uh, but identifying what's better is a huge problem on its own. It's the whole evaluation discussion that we are always having. Identify the metrics, the evaluation data set, and everything. So this is a prerequisite for us to be able to do automatic prompt optimization. We need to be able to score a candidate before being able to optimize this process. So the idea, you start with some very simple prompt, and then you try different ways, different strategies to make it automatically better or different in many ways. Um, so the blog post first goes through some of the older or the initial proposals on how to do this. They are more they're more reinforcement learning based, like either attaching something to the model or training a model for this specific task. So an auxiliary learned language model that will try to optimize the base prompt, or prepending. For me, this is hacky, really hacky. So training a prefix that is a string, it doesn't need to make sense, but just the fact that you add that prefix makes the prompt magically better, because you don't know the how the probabilities really work within a large language model. So by appending random stuff in the beginning that is optimized through the training process, you can make it magically better, even if you don't know why. Of course, this is very prone to not working really well in the next iteration. So we call it hyper optimized, overfitted to the application, but it's an approach. And yeah, reinforcement learning based optimizers where you give like rewards for improving, like you swap specific tokens and things in the area. But I want to focus more on the more recent ones. I'll try not to go too much today because I want to discuss. I think it's better to discuss rather than just mention this. But one is automatic prompt engineering. So you'd have a pool of let me open to make it easier. It's open right over here. So let me go to ape. Uh, it's way below. Uh, trying to find the specific. Okay, it's this one. So it's you take a lot of yes, a, ape. I'm trying to remember exactly what it does and what is different from optimization. But yeah, this one is it changes the prompt itself with some pool of ideas on how to iterate of the prompt. Yeah, so you can change, you can give some ideas for some specific tokens that you can replace, and then you're gonna test all of these variations and try to find the best over different iterations. The optimization one is different in each yeah, the optimization one is different where the LLM judges the based on the mistakes that the previous made. So it tries to explain, it creates a critique over the responses of the last prompt. And based on that, it tries to create a new prompt or a series of new prompts. So, for example, it sees that I don't know, the answers are not in code or there's markdown in the answer. So we can try to propose, it identifies that as a problem and tries to propose a new prompt or a series of new prompts that attempt to fix those issues. And you can have those as an iterative process as well. And finally, the other one that it had is OPRO, or is OPRO, which is well, where's the name? Oh, oh, find it. Yeah, optimization by prompting. The idea on this is that you don't have this kind of setup of a task or anything or a scorer and you generate candidates. Everything is managed through the LLM. So the idea here, that has an example, is that you keep iterating but you keep appending the previous results to the LLM, and the LLM tries to keep constantly finding better answers or better prompts that will achieve. So the LLM itself is the makes the process like the gradient of like replaces the function of scoring or ID or adding ideas. We also can have the score over here, but optimization itself is done by the LLM itself, by the LLM, it's not by an optimizer. So it's an even different approach. They also go about some other methods with heuristics. It's hard to go over all of them and remember what each one of them does, because there's a lot, but it was a very interesting see the ideas and how you can even combine those in some ways. But there was one GIF over here that I like to explain what most of these are doing. Yeah, this one. So what it is you take the zero prompt to generate a bunch of prompts, and then you pick the best, and then you keep repeating this with a pool of the best prompts. Ideally, this will converge to some to the best possible uh, performance given that specific state. Yeah, that's the overall like the overview of the blog post. Any ideas? Any comments? Any
Yeah,
applications?
to the last one that you mentioned, it was using like errors corresponding to the prompts to generate that gradient that would like dive in to like converge. Um, I guess like how exactly, and I was kind of like confused on that, is like how are they evaluating that the error is helping to get to like a convergence point of something? I'll send like a text section so we can look at it
Yeah,
too. Just a second.
it's so so how it's you can define either a minimum threshold for stopping. You can define that it should go through X amounts of iterations, or you can define that after a while it doesn't like the scores keep not changing. Like there are no more errors. The scores have been the same for 3 or 4 generations. So trying to do something different will not change anything much. Those are some of the stop conditions.
Okay. Let me see about finding this section. But yeah, we can probably skip that for now because it can take me a little bit of time.
Mhm. I really like this blog. Uh, they are not easy reads, like they are not quick reads compared to most blog posts, but they are thorough. They are worth they give a good survey of a lot of different papers. So I find this a lot easier to go through than papers. Ideas for applications?
I think I'm going to say what I always say. I think this also highlights that what you are evaluating makes a difference. Um,
Mm-hmm.
I think so. If you are evaluating the wrong thing, or if you have a data set that doesn't evaluate in the right way, then you feed like that feedback loop is just gonna
Mm-hmm.
kind of um, exhort that. So they didn't really go into like what is a good thing to use there. I think they mentioned accuracy and log probability. So I would be interested in like what are things that you can do to um, make sure that you are evaluating the right thing, and if they did this with different evaluation metrics. What was interesting to me is also the kind of gibberish. They had the gibberish in the reinforcement learning prompt and in the grips prompt where you like edit things.
Mm-hmm.
And they say like it contains like semantically awkward phrasing, but it works well, which is
Yeah.
quite interesting because that's just the way the LLM is like built. Is it's not a human, so it like reasons differently. So that was interesting.
Yeah, the probability network gets messed up because of like it builds a network around that. They
Mm.
even mentioned that like yeah, the language that LLMs speak is different than humans. And we're trying to use the human language, which is the whole point of LLMs in itself, but it was an interesting one.
Yeah, and they
I think
mentioned that it could be like the gibberish could be transferable to other models and it would still improve it than not having the gibberish there. So I found that interesting.
I found it a little bit too much of a magic. Well,
It is.
if you have a solid evaluation framework, it doesn't really matter because if you have gibberish, and it doesn't work, you're gonna catch early, so you
Yeah.
can update or remove it. But yeah, it's a little bit of magic. Like me on what to evaluate always depends. But for example, you could use this, like we are working with agents, and one of the difficult parts of agents is to make the output of the agent be consistent into requesting tools, for example. Make sure that it always requests in a JSON format or something on those lines. We could use automatic prompt optimization for that to make sure that we can use both fine-tuning and automatic. They will always be complementary solutions, but on this case, we could use it to improve um, the likelihood of actually outputting JSON. And on that case, we actually have a good uh, evaluation, which is just go through JQ or something,
Yeah.
or something on those lines that will uh, at least test if it's a valid JSON or not.
Yeah. I also wonder, like we learned in previous chapters of the book, that including a not in your prompt, like saying it isn't this or this is wrong, like really helped the LLM to reason. So I wonder, like, if you can use the gradient to optimize for getting the most errors, kind of, if that makes sense, um,
Hmm.
to get the statement that has like the most negation and use that. I was wondering about that.
Where it also makes sense because they can say, okay, make sure that the sun is not blue and it doesn't really matter anything. So that's the optimization constraint.
Mm,
I think one optimization constraint is also like keeping the prompt small, because this causes token usage and whatnot. Um, and I'm exploring a case now where part of the prompt might not be really useful or might not be given, but it's hard to quantify that. So it's also making it more complicated, but also can we remove parts of the prompt? Can we remove, like, you remember the Chaos Monkey experiment where you randomly block parts of your infrastructure to see how bad the infrastructure reacts? We could do the same with prompts, like randomly blocking parts of the prompt to see what
mhm.
would be the impact on the evaluation score. That would allows us to reduce a little bit or shrug it off the the size of the prompt.
Yeah. Like you can use an automatic optimizer to, like for RAG, for example, to figure out how many search results is actually the optimal.
Yeah,
You can run it
exactly.
like 1, 2, 3, 4, 5, and then it finds like the optimal. Yeah,
Yep.
that's a real life
Uh,
application we can use.
for for custom models, I want to explore this because we have a big problem of too many models and too many prompts. So we keep while.com, we has like one feature, like every feature has one model and one prompt. We need to support 4, 5, 6 different models, and we have a prompt for each model, and then for each feature, and then the number explodes. If we could have a way to optimize prompts based on a starting prompt, like you take the .com, and then you optimize for the specific model to a certain threshold criteria, that would be awesome because that would remove so much effort on our side. Uh, yeah, I even opened a Spike because I want to start taking a look at this.
Yeah. And also like remove effort, but also like increase the quality of the customers using those models, because like we're just human and we're not going to spend like as much time on optimizing 6 models manually.
Hmm.
So yeah, that's sounds really interesting.
Yeah, it goes a lot of time into those.
Sure.
Also keeping up with versions with features on the .com, so we are behind a few features and try to always be up to date with new prompts. This is really hard for us to achieve. like feature parity. Uh, so that could be a way.
Yeah, I wonder if we can have like a pipeline, like a nightly pipeline that takes a prompt as a start prompt and run it through like different optimizers or even just one. And then if the results improve by like a dramatic amount, we can say like maybe it's time to look at the prompt again. If it's
Yeah,
like to catch the case where we don't update versions or like we bumped a version, we didn't update the prompt,
yeah.
and we see like if there's the divergence. I think that would be nice.
Yeah, I'm really looking forward for this because a problem that we're having for a while. So if it works, it would be awesome. Like it would be really great.
Yeah. What
It
about other
remind On the time of machine learning, this reminds a lot of hyperparameter optimization, which is every model has a few parameters that you can configure, like the size of the model or the depth of the tree. And it always, even at the machine learning time, they had like they most people like a few people would find this weird because it's just like hacking to answer in a better way. But if it works, it works. Like I don't see the point. Like in theory, perhaps academically, it's not the best thing in the world to exist, but if it works, it works. I don't care.
it's trial and error, like
Yeah.
yeah.
Like, whoever, like all of us at some point, just try like set up saw a bug and tried just moving code line by line to see if it works, and if it works, it works. Like it doesn't matter. Okay. Any other comments? Any other ideas? Any other discussion? Nope. Cool. So I'm gonna call this off. Thank you everyone for joining and for reading and accompany and making each other company on this afternoon. The next one I'm gonna schedule soon, or I'm gonna ask someone to schedule, is gonna be over the book, and I think is already gonna be the next year, or we can have one more in November before the end of the year, because December I don't expect anyone to be around. December is the month that doesn't exist. Okay.
Sounds good.
Thank
Thanks
you
for the
all.
work you're putting
Thanks.
in, Eduardo. Appreciate it.
Yeah.
It's always fun to go through this. Have
Thanks
a
so
good
much.
one. Bye bye.
Thank you. Bye.